बच्चों, so here we have a question from IITJEE 1989. It's a very old question, a subjective question. Okay, let's look at the question first. A gas of identical hydrogen-like atoms has some atoms in the lowest energy level A and some atoms in a particular upper energy level B, and there are no atoms in any other energy level. So the gas has got only the all the atoms are of the same type, of the same element, but the atoms are only in two energy levels. Either they are in the ground state or they are in some excited state for level B. Okay, now the atoms of the gas make transition to higher energy level by absorbing monochromatic light photons having energy of 2.7 electron volts. So now they are absorbing some energy. Subsequently, the atoms emit radiation of only 6 different photon energies. This is important. We will use this. Okay. Some of the emitted photons have an energy of 2.7 electron volt. Some have more energy and some have less energy. We will use this as well. Some have more, some have less, and some have 2.7 electron volt. Okay. So we have given three questions. Find the principal quantum number of the initially excited level B. Find the ionization energy of the atoms. Find maximum and minimum energies of the emitted photons. So first of all, we have to find this principal quantum number of B. Very easy. Understand. We know that only 6 different photons will be emitted. Right. So that means if you have a ground state over here, this is your ground state. Alright. And this is your and level B. Okay, level B will be somewhere, we don't know the quantum number for level B. There might be other energy levels in between ground and level B. And then we have the nth excited state. Okay, so the atoms at level B absorb 2.7 electron volt and jump to n. So let's write that over here. They absorb 2.7 electron volts to jump from level B to n. Okay, now, while returning from N to ground state, how many types of photons or wavelengths will be emitted? So, we can write down types of photons will be equal to NC2 combination, right? So, types of photons will be 6. So, 6 is equal to N times, sorry, N minus 1 by 2. जब ये equation solve करोगे, you will get N is equal to 4. Okay, N is equal to 4. अब लेवल बी जो है वो ग्राउंड स्टेट पे नहीं है, ग्राउंड स्टेट से ऊपर है. तो ग्राउंड और 4 के बीच में लेवल बी क्या हो सकता है तुम्हारा? लेवल बी कैन बी 2 और 3. करेक्ट. Either it can be 2 or it can be 3. So let's look at the two possibilities. Okay, so we have ground state, let's call this ground. Then we have level B, that is 2. Then we have 3, and then we have level 4. Okay, or alternatively you could have level B will be at 3. Okay, so one of these two is possible. Now which one is possible, that we need to see. Okay, now try to understand something. When the electron is at the fourth energy level, so while returning from the fourth energy level, it can take this transition. Okay, it can take this transition, and it can also take this transition. Okay, so this, first of all, yeah, the transition from B to 4 will be 2.7 electron volts. Now this transition will emit photon having energy less than 2.7. Okay, let's call this X, Y, and Z. So X will be less than 2.7, Y will be equal to 2.7 electron volts. Okay, why? Because 2.7 is for transition from 2 to 4, B to 4, right? And this is again coming from 4 to B. So they should be equal, and Z will be greater than 2.7 electron volt. Now let's look at this transition. So in this case, this is 2.7, right? While you can have this transition X, Y, Z. So X is equal to 2.7 and Y and Z are greater than 2.7 electron volts. Okay. In this situation, these are your possibilities. In this situation, these are your possibilities. And what does the question say? The emitted photons can have energy equal to 2.7, more than 2.7, and less than 2.7. So in this case, we are getting more than 2.7, equal to 2.7, and less than 2.7. While here we are getting only equal to or more than. We are not getting less than 2.7. That means according to question, this is not possible. तो हमें principal quantum number मिल गया. Principal quantum number for B will be 2. Okay. So this is my answer to the first part. Now find the ionization energy for the atoms. So let the atomic number be equal to Z. Then the transition will be what? 13.6 Z square. You're going from second level to fourth level. So I'll write down 1 by 2 square minus 1 by 4 square. This is the energy for transition from second level to fourth level, and that we know is equal to 2.7. So this is equal to 2.7. When you solve this equation, you will get 13.6 Z square is equal to 14.4 electron volt. Okay, and this will be your ionization energy. Okay, from ground state. So we found the answer to second part, that is 14.4 electron volts. Clear? Now find the maximum and the minimum energies of the emitted photons. So the maximum energy will be for transition from 4 to ground state, and the minimum will be for transition from 4 to 3. So let's calculate the minimum first. Minimum will be from 4 to 3. So the energy will be how much? E minimum will be 13.6 Z square, 1 by 3 square minus 1 by 4 square. Okay, so this is equal to, this will be 14.4, we just calculated, 1 by 9 minus 1 by 16. So when you solve this, you will get 0.7 electron volt. This is your minimum photon energy. Now let's calculate the maximum. So maximum will be from fourth state to ground state. Okay, so E max will be 13.6 Z square, 1 minus 1 by 4 square. Okay, so 13.6 Z square is 14.4, 1 minus 1 by 16. So this will come out to be equal to 13.5 electron volt. So this is your answer for the maximum photon energy. Clear?